Here's a quick note about the inertial balance lab that we did in our physics class. If you remember, we had an inertial balance, which is basically you have a table. I'll do a bird's eye view of this. A table with a spring attached out to a plate, and we can clamp on different weights onto this plate and pull it back, and it'll oscillate back and forth with a certain period, and we can time that period. And a period, of course, is given by a capital T. It stands for a time period. And in this case, a period is how much it takes for something to oscillate back to the starting point. So it might start here and then go over here, and then back. And we measure how much time it took to do one complete cycle. Or if it started over here, it goes all the way over here and all the way back. It'd still be the same amount of time, the period. And what we did is we tried to see if more mass would affect the period. If we add more mass, how does that affect the period? And so we did that, and when we did that, we graphed period versus mass. And this lab doesn't always come out the best. It's hard to see it, but what we end up getting really is kind of like a curve like this. And so when we did our R-squared value through this thing, we got something that probably is fairly close to a straight line, but not quite. So we want to modify the y-axis usually to see what is the relationship between period and mass that would actually give us a linear relationship. So what we want to do is we want to kind of straighten this line up. We want to bend this up a little bit so we have a linear, straight line relationship. So to bend this up a little bit, that means we're going to try, our first attempt is going to be to square the period. So when we did that, we squared the period and graphed it again versus the mass, we got a much straighter line, and we did an R-squared value on here, a regression coefficient, and we see that it's a lot closer to 1. So that's how we prove mathematical relationships. So we know then that period squared is proportional to the mass. This isn't an equation. We don't have period squared equals and then know what the entire equation is, but somewhere in that we do have t squared equals, and then somewhere in this big equation we have mass in there. We know that because that's period squared is related to the mass. Everything else it remains constant, then the period squared is going to be proportional to that mass. So in your E-Lab you might have a problem that says something like 4 kilograms was put on the inertial balance and had a period of 3 seconds. So then the question is, what would a 8 kilogram mass have? So you can set up a ratio here. I want to know what the period is for that. You can set up a ratio. You could do period squared, or you could take the period squared, so like 3 squared over its mass, 4, right? Would equal t squared over its mass, which is 8. And then you take 9 times 8, 72 divided by 4, square root of that, and you'd have your period. You can't just take 3 over 4 equals t over 8, because it was not a linear relationship between just the period and the mass. It was period squared versus mass. So if you take these relationships and put them into a ratio form, you got to square the period and not square the mass to be able to figure out the period. Hopefully that makes sense.